Hi everyone, welcome to Algebra 3. Today we're working on 7-1 Day 2, special triangles. Your essential question says, how can special right triangles help you identify the 6 basic trigonometric ratios? Alright, now before you panic, hopefully maybe you recognize these from geometry. And I'm guessing you didn't love them in geometry, but I promise they're going to make your life easier in Algebra 3. Right now I would stop, I would take a picture of this slide because you're going to use this to solve every single problem you do today. So my first thing, we have 45, 45, 90 triangles. The two features that are important to us are the angles are 45, 45, 90. My two legs, these two sides here, they're both A. And my hypotenuse, the one across from your right angle, it's A root 2. And now we can replace A with numbers. So maybe this is a 2. Let's use an actual pen. So maybe this is 2. That would mean this is 2, and that would mean this one is 2 root 2. You would leave your answers just like that. You don't have to multiply 2 times the square root of 2. So all of your answers today, if there's a square root involved, it will keep the square root. Your second one are your 30, 60, 90 triangles. Again, you have a 30-degree angle, a 90-degree angle, and a 60-degree angle. Notice that your 30-degree angle is across from your shortest side, which is A. And then your 60-degree angle is across from your middle side, which is A root 3, and then your longest one is your hypotenuse across from your right angle, which is the biggest angle. It's 2A. Again, for this one, A is a number, so maybe A is 2. That means that this side would be 2 root 3. Again, we leave it just like this, and this one would be 2 times 2, which is 4. All right, we're going to go ahead and start looking at the problems with our trig ratios. All right, my first one, notice we have a 45-degree angle. So that means we're going to have a 45, 45, 90 angle. Remember, that tells me that the two legs are going to be the same size. So the first thing you're going to do is figure out how big y is. If it helps you, on your last slide, remember we said this one was A, this one was A, and this one was A root 2. Notice right now I have 8 equals A and y equals A, so that means y equals 8. So you could put 8 right up there. X is A root 2, so if I plug in 8 for A, we'd have X equals 8 root 2. Let's write that somewhere where we can actually read it. So here this would equal 8 square root of 2. And again, that would be your X value, 8 square root of 2. Now at this point, you can go ahead and label your triangles. We're going to go ahead and just do our right triangle trig just like we always have. 45 is the angle we're looking at. We're looking at the one that's already written inside of it. And then across from that is going to be our opposite. So this is O. My hypotenuse is across from my right angle. So this side here, this is H. And then my last one, the one that's next to 45, is going to be my adjacent. And then we're going to plug in all of our things into our sine, cosine, tangent. So remember, sine is opposite over hypotenuse. One second, let me change the color here. So we have O over H. So right now my opposite is y equals 8. So we're going to have that as equal to 8 over the hypotenuse, which is 8 root 2. Now notice right now you have an 8 on the top and an 8 on the bottom. You can divide those out. When you do that, they cancel, and you get 1 over the square root of 2. Now that's a problem for us because we can't have a square root on the bottom. So to get rid of it, we're going to multiply the top and the bottom by the square root of 2. So times root 2 times root 2. On the top, you get the square root of 2. On the bottom, you multiply inside and get the square root of 4. And again, the square root of 4 is just 2, so I have root 2 over 2. So now I kind of just took up the whole space, but that means my answer for this one is going to be root 2 over 2. All right, I'm going to erase a little bit so we have some room to work. And we're going to move on to cosine. All right, for cosine, we're going to do the same thing. Remember, for cosine, you do AH, adjacent over hypotenuse. Again, on this one, my adjacent side is going to be 8. So we would have 8 over my hypotenuse, which was 8 root 2. Now remember, I erased all of our work, but when we did sine, we did 8 over 8 root 2. So that means that these two are equal. So this one is also going to be root 2 over 2. And the last one we're going to do is tangent. Tangent is opposite over adjacent. And so my opposite side is 8. So this one equals 8. My adjacent side is also 8. So really this whole thing is going to be equal to 1. So right now we found our sine, our cosine, and our tangent. Remember, we can just flip these numbers to find each of the ones underneath them. So sine goes with cosecant. So to find cosecant, I would flip whatever I have here. Now to make my job easier, I'm going to start with the one that we were given, the one that we sort of rearranged. So I'm going to do 8 root 2 over h. Remember, we're really just doing h over o. Notice that we have an 8 on the top and 8 on the bottom, so those guys cancel out, and you're really just left with a square root of 2 over 1. There's like a sneaky little 1 down here, and you don't even have to write that. This one is just going to equal the square root of 2. Now we have to do secant of 45. Notice that when we did it before, our sine and our cosine were the same, so that means that my cosecant and my secant will be the same. So this one is also going to be the square root of 2. And then my last one, again, we have to do a over o. Again, we would flip it. If we're flipping this fraction here, we still have 8 over 8, which is going to equal 1. So notice when we do these, the ones that match are sine, and let's make that red, sine and cosine, cosecant and secant, and then tangent and cotangent. Now here's the thing. I know we just did a lot of work. I know you're like, oh my god, Miss Sylvester, square roots, they're the worst. I hate them. This is hard. But here's the thing. Because every triangle we're working with is a 45, 45, 90 triangle, your sine is always going to be root 2 over 2. Your cosine is always going to be root 2 over 2. Your cosecant is 2. Your secant is the square root of 2. Excuse me. Cosecant is also square root of 2. And then tangent's 1 and cotangent is 1. So no matter what our side lengths change, all of the red numbers, all the ones that I've circled in red, they're going to be the same. So if I go to my next problem, so sine, where I have another 45, 45, 90, my numbers are going to stay the same. So notice tangent of 45, that's still going to be 1. Cotangent of 45, that's still going to be 1. My sine and my cosine, my cosecant and my secant are also going to be the same. I'm going to go back. Sine are square root 2 over 2. And cosecant and secant are just root 2. Now, don't get me wrong. If this was like a normal school year and we were in class, I probably wouldn't tell you this. But because you're doing it on your own and I want to make sure you're actually successful on it, know that these guys, for every 45, 45, 90 triangle, they are going to equal this. So this is true for all 45, 45, 90s. So I would take a picture of this slide right here, what I've circled. Those should be your answers for all your 45, 45, 90s. Now the only thing that is going to change are your x and your y values, or the two numbers that they ask you for at the beginning. Sometimes they call it like a and b. So you do have to be careful. Now we found x and y on the other slide. This one we're going backwards. So notice I have a root 2, it's my hypotenuse. And then each of the other ones are a. A is just your number in front of your square root. So notice that I have a 5 in front of my square root. So that means x equals 5 and y equals 5. That's the only thing that's going to change is your x and y values for your 45, 45, 90 triangles. All right, let's talk about 30, 60, 90s. All right, we're going to do our second example. Here's the thing. Hang with me here. I'm going to show you the math because I feel obligated to show you the math. But at the end, like we did with our 45, 45, 90s, I'm going to talk to you about how you can figure out your answer every time. Because they will be the same for all of the ones that are sine, cosine, tangent, cosecant, secant, or cotangent of 30. So for all of the ones that have 30 as their angle, our answers are going to be the same. But I do feel obligated as a math teacher to tell you how I get to that number before just giving it to you. Oh no, I just lost part of my little pen that I used to write, stylus, that's what you call it. All right, let's go. So we are still doing, well, we're doing 30, 60, 90. Remember for 30, 60, 90s, your shortest side is going to be A, your hypotenuse is 2A, and your leg, your long leg, is a root 3. Notice how right now I have A equals 3, so I can just go ahead and plug that in. So we're going to do 2 times 3 equals 6. And then for n, we're just going to do 3 root 3. And I'm going to go ahead and leave my square root of 3 as part of my answer. Now we're using 30 for our angle. So I need to figure out what my opposite, my adjacent, and my hypotenuse is. Oh, by the way, instead of x and y, it should say n and m. And we already found that n was 3 root 3, m was 6. All right, back to what I was doing. So we're going to figure out our opposite, our adjacent, and our hypotenuse. So if this is 30, across from that you have 3, which is going to be O. Your adjacent is going to be N, so this is A. And then your hypotenuse is going to be 6. Again, for sine of 30, we're doing opposite over adjacent, or opposite over hypotenuse, excuse me. So we have O over H. My opposite side is 3. And my hypotenuse is 6. We do have to simplify. So if I do 3 divided by 2, I do 6 divided by 2. I get as my answer 1 over 2. Again, this is going to be my answer for sine of 30. For cosine of 30, we're going to do adjacent over hypotenuse. So we're going to do A over H. So we're doing 3 root 3 divided by 6. Again, I can divide the top and the bottom by 2, or by 3, excuse me. You're looking for the biggest number that goes into them. And for that one, my final answer is going to be root 3. Sorry, I don't know why I keep writing that. Over 6 divided by 3 gives me 2. So my answer for that one is going to be root 3 over 2 for cosine of 30. And then for tangent, we're going to go ahead and do opposite over adjacent, which is going to be 3 over 3 root 3. First thing is first, those 3's are going to cancel. And then I can't have a square root of 3 on the bottom, so remember I'm going to multiply the top and the bottom by the square root of 3. Sorry, I'm like kind of out of space down there. When I do that, we would have the square root of 3 on top. On the bottom, we'd have the square root of 9 because I multiplied 3 times 3. And then remember the square root of 9 is in fact 3. So my final answer would be root 3 over 3. And then this would be my answer. Now I've just highlighted all of your answers in yellow. I'm going to go ahead and box them, not in that color. Oh gosh, everything's just not working today. All right, I'm going to go ahead and outline them in black. So 1/2, root 3 over 2, and root 3 over 3. Those are your 3 answers for sine of 30, cosine of 30, tangent of 30. Those will work no matter what your side lengths are. If you're looking for sine of 30, it's going to be 1/2. Cosine of 30 is root 3 over 2, and tangent of 30 is root 3 over 3. All right, then we're going to find cosecant of 30. Remember, for this one, you're essentially just flipping whatever tangent was. So we're going to end up doing 2 over 1. And 2 over 1 is just 2, so 2 would be my final answer. For secant, we're going to go ahead and flip our previous answer for cosine. We're going to flip this one. When I do that, we're going to have 2 over the square root of 3. Remember, we can't have a square root of 3 on the bottom, so we're going to multiply the top and the bottom by root 3. And we would have 2, this is a 3, 2 root 3 over the square root of 9. Hold on, let me just, I'm really just struggling today, gal. So we'd have 2 root 3 over the square root of 9, which would really be 2 root 3 over 3. And again, this would be our final answer for secant. And then our last one, cotangent, we're going to flip this one. we would have 3 over root 3. Again, we can't have the root 3 on the bottom, so we're going to multiply the top and the bottom by square root of 3. We would get 3 root 3 on top divided by the square root of 9, which is really 3 root 3 divided by 3. Again, my 3's cancel, and we just have the square root of 3. All right, and that would be our final answer. Again, for cosecant of 30, 2 will always be your answer. For secant of 30, 2 root 3 divided by 3 will be your answer. And for cotangent of 30, square root of 3 will be your answer. Again, I would take a picture of this, all of the things I've outlined in red. Those will be your answers for each of the ones that they're under. All right, we're going to do one last problem. I'm so sorry this video is long, but it does change a little bit when you use 60 instead of 30. The first thing I noticed for this one is they give me my hypotenuse. Remember, this is the same as 2a, so 4 equals 2a. Your short side is a, your long side is a root 3. Now, if I know 4 equals 2a, I can go ahead and divide both sides by 2, and I get a equals 2. So that means y is going to be 2. That means x is going to be 2 root 3. So for here we have 2 root 3. For y we have 2. Again, we're going to figure out our opposite, our adjacent, and our hypotenuse. So across from 60, you have our opposite. So our opposite is going to be 2 root 3. Our adjacent is going to be 2. And then our hypotenuse is going to be 4. For sine, again, we're doing opposite over hypotenuse. We said our opposite side was 2 root 3. And our hypotenuse was 4. For this one, I can divide those both by 2. And when I do that, I get root 3 over 2 as my answer. We'll highlight it in yellow. All right, so for cosine of 60, we're going to do adjacent over hypotenuse. So a over h. My adjacent side is 2. My hypotenuse is 4, so we have 2 over 4. Again, I can divide those both by 2. And when I do that, I get 1/2. And that will be my cosine of 60. And for tangent of 60, we have opposite over adjacent over a. My O was 2 root 3, and my adjacent was 2. And if I have 2 root 3 over 2, remember, since I have a 2 on the top, I have a 2 on the bottom, they cancel out. Our final answer will just be the square root of 3. And again, if I highlight that one, that is my answer. All right, I'm going to outline these in red. So for sine of 60, no matter what your side lengths are, your answer will be root 3 over 2. Cosine of 60, you'll have 1/2, and tangent of 60, you'll have square root 3. Again, those answers are the same every time the second number you have, or the number after your trig ratio, is 60. All right, let's look at cosecant, secant, and cotangent. So again, for cosecant, we are just going to go ahead and flip whatever we did for sine. So we're going to have 2 over root 3. Again, I can't have that root 3 on the bottom, so I'm going to multiply the top and the bottom by root 3. I'm going to shrink this a little bit. When I do that, we will get 2 root 3 over the square root of 9, which, remember, is the same as 2, I forgot my 2, root 3 over 3. All right, for secant, we're going to go ahead and flip 1/2, so we'd have 2 over 1, which just equals 2. And then for cotangent, remember there's a sneaky little 1 here. So when we flip it, we'd have 1 over root 3. Again, I'd multiply the bottom by root 3 and the top by root 3, which would give me root 3 over the square root of 9. which would really just be root 3 divided by 3. I'm going to go ahead and highlight these because these are your answers for cosecant of 60, for secant of 60, and for cotangent of 60. I'm also going to go ahead and outline them in red. Again, at this point, I would take a picture of your slide. Anything outlined in red is going to be your answer for any of those involving 60. Again, your x and y's, these will change. All of the trig functions, all of the values below x and y, those stay the same. All right, I'm sorry your video is so long, but thank you for watching. Good luck in your homework. Please let me know if you have any questions.